adjacent means next to. Okay, they are next to each other. Now you got to be careful here because there are a couple of possibilities. So you might think that these angles are next to each other, but they are not. Okay, adjacent angles look more like this. These two angles are adjacent.
All right.
These two angles are adjacent. They are next to each other. So when it says best, best means that there's some of these answers are partially true, but there's one answer that's fully true, I guess. Any of these that you think you can eliminate based on what I've just said?
Let's see. Probably supplementary.
Okay. They could be supplementary, but they don't have to be.
Yeah.
The
And
example over here on the
then
right is the vertical. These are considered vertical angles because they share that little place of intersection. That is also not required. So do adjacent angles share interior points? Like is something in the interior here, also in the interior here?
looks like it.
So think about, I don't know if you have a brother or sister, think of this as like a wall. You got your space, they got their space. Is there any shared space?
Oh, well then no, I guess.
Yeah. So that is it. That is out. And then this last one would be correct.
All right.
All right, let's move to number two. Fortunately, I just can't. I mean, they just like to have you have more information on these, but what is a requirement of adjacent angles? Didn't we just do this one? Maybe I snipped in the wrong question.
No, that's number one. You just did number two.
All right, what is a requirement of adjacent angles? Didn't we just?
No, the
Okay.
first one was which of the following statements best describe adjacent angles?
All right, so again, I'll draw some adjacent angles here. There's an angle, and then there's an angle. So these two angles are adjacent. Okay, what do they share down here?
Point.
A point, and that point is called a vertex. So while adjacent angles could be vertical, I'm sorry, they're never vertical. They could be supplementary. They do not share interior points, but they are a vertex. This is a shared point there. All right, let's look to number three. All right, if P is the midpoint of RS, so let's draw that. Here's R to S, and here's T. So midpoint means right in the middle. Okay. So if it's right in the middle, that means that RT is congruent to TS. Okay. Now in geometry, you'll often see the word definition of. The word that follows is the word that they're asking about, or the thing that they're asking about here. So the reason that these segments are congruent is because T is a midpoint. That is the definition of a midpoint.
All right.
The other thing you do here is say, well, we're not talking about angles, and yeah, I mean, I guess these other ones could make sense if you weren't really following the letter of the geometry world, but that's probably sufficient here. All right, let's take a look at this next one. All right, here we go. So it says, what angle relationship best describes angles AFC? So it's when you're given an angle AFC, you have to think of it as a path. A to F to C. A to F to C. So it's that angle right there. The next angle is DFB. Let me use a different color here. Angle DFB. All right, so that's this one down here, D to F to B. That's this angle down here. All right, E to F to B. Is that clear?
Yeah.
Okay. So are these angles, I guess we'll just go one by one. Are they adjacent
Um,
based on what we've been talking about?
they look like it.
Adjacent means next to each other. Like
Oh,
while these
no.
do share a vertex, but are they next to each other?
No.
No, so they're not adjacent. Okay. Are they complementary? So complementary means they add to 90 degrees. Do they add to 90 degrees?
No.
Maybe, but we don't have any way to know. So probably not. A linear pair adds to 180 degrees. So this would be like a straight angle. You can think of it as a straight line like that.
Yeah.
Okay, and this does not fit that. So it must be the last one. So what exactly is a vertical angle? Well, to make a vertical angle, you first draw a line and you draw another line. And this angles that I'm drawing here, they are considered vertical angles. That one and that one. But it's also the case that the other ones here, these are also vertical.
Yeah.
Can you see that? I mean, tell me if it's unclear.
No, I get it.
Okay. So when they share a vertex, but they're not adjacent, which is the case here, they share a vertex, but they're not adjacent, they are vertical angles.
All right.
All right, let's look at another one here. All right, the presence of an angle bisector will result in what type of angle? So again, kind of an English thing here. Any idea what the word bisect or bisector means?
To like cut in half.
Cut in half, yeah. So what's something you've cut in half lately?
Um, cucumber.
Cucumber, okay? You sharing splitting a cucumber, we're gonna cut it in half. You get half, I get half. What do we know about each half typically? I mean, in a fair world,
It's 50-50.
50-50. So which of these words here might mean that?
Um, uh, vertical, like next to, or complementary.
So we got to do some definitions here. So complementary means it adds to 90 degrees.
Oh,
Now they could be both 45, like that's a possibility, but it could also be 70-20, and then it's not the same. Vertical means that they are congruent, which I could see why you might go that direction. Um, Congruent angles is the answer here. Supplementary is that they add to 180 degrees. So you're probably starting to see that you need like have some of these definitions down. You need to make a Quizlet. You got to do something to be able to remember this stuff because it's going to come back over and over and over again in the class.
yeah.
So that's my question to you. What are you going to do to try to remember this stuff?
Probably make a Quizlet.
Okay,
I used
good
to use it in
strategy.
the past.
Yeah, maybe there's already one out there, but you need to know these words. It's a lot like English class, and they give you that vocabulary list for the week. You have to figure out a way to learn it.
All right.
All right, I'm gonna just step away for 30 seconds. It's not that phone call. I need to heat up my coffee, but I'll be right back.
All right. Take your time.
All right, I'm back. I see you sent over a bunch of stuff. We'll resume here
Yeah.
shortly. So here we go. Snipping in number 6. So they're saying that this right here in the middle is a angle bisector. And we just said the word bisector means that it cuts the whole thing in half. So when you cut the whole thing in half, what do you know about the pieces?
They're both 30.
About 30. So which of these says that?
The second one.
There you go. All right, if C is the midpoint of AB and AB equals 20, what is AC? There are two types of questions that you get in this course. One is they give you the picture. One is you need to draw the picture. And you don't have to be an artist, you don't have to be really good at it. You just have to do something. You have to take some step. Now you probably remember in problem solving, they would say, draw a picture. And it was a silly problem about, I don't know, laundry and baskets. And it's like, why do I need to draw a picture for that? Well, you didn't, but here you actually do, because visually you can learn something from it. So A to B, and then C is the midpoint. Now A all the way to B is 20. So what are the individual sections going to be when you split them up? What does each person get?
10.
10. All right. Keep going here. All right, if LR equals 12 and PR equals 4, find LP. So what I'd like you to do is look at just the first part of the answers here and tell me which two you're choosing between. So use the information here to figure out, like, is LP 8 or is it 16?
I think 8.
You seem uncertain.
I don't know. I'm not sure.
This is not meant, I'm not trying to trick you. This isn't meant to be like a really difficult problem. If
Well,
you were to draw this, the whole thing is 12 and this little segment is 4.
I was just thinking I was looking at the second one and it says 8 plus 4 equals 12. So
Okay. So yeah, so I was going to get to that, but I was hoping you would get it down to it's either the second or the fourth. Okay. And then it comes down to, well, what's the reason why? What's the reason why? Well, yeah, 8 plus 4 is 12, but so is 12 minus 4, 8. Okay, so we've got to now decide which one it is. Okay. And that's where the geometry is like, it's like, well, which one is it? Well, you're in the part of the course we're using the segment addition postulate. You're saying that these two segments add up to the total. Okay, but this one is also true. But what you have to start with is the segment addition postulate. You have to say that the pieces added together make up the whole.
yeah.
All right, so I'd probably recommend going with the second one. You are welcome to modify as you see fit.
All right.
Any questions on that?
No.
All right. Here we go. If the measure of angle ABC is 70, so they're saying the whole angle measure here, the whole angle is 70 degrees. But they just want the angle measure of A to B to D. That's this one. We know the other one is 40. So which two answers are we choosing between?
Um.
Or what is the right answer for that angle?
40.
It is, well, this one is 40. What about the green one in green?
Oh. 30.
It is 30. Okay. So which two answers could it be? Which two answers have 30 in it?
The second one and the third one.
Okay, so we know it's not the first, it's not the fourth. Now you got to decide, well, what's different between the second and the third?
One subtracting
Okay,
or
and the other one is
addition.
addition. So again, it's kind of like the previous one. So the angle addition postulate says that if you take one angle and you add it to the other angle, you get the whole thing. So it's like the measure of angle 1, 30, plus the measure of angle 2 equals the measure of the whole thing. All right, and then to solve for it, you do use the subtraction property, but it's the angle addition postulate, just like in the previous problem, it was the segment addition postulate that allows this to work. Part plus part equals whole.
So the addition.
Yes. Yes. I'm trying to get you to recognize the main words, theorems that you're going to see in this course. Angle addition postulate, segment addition postulate. We talked earlier about bisector. What is complementary? What is congruent? What is vertical? What is supplementary? I know it's not exciting, but this is the main takeaway from the course, is knowing these words and what they mean.
Yeah.
Believe me, this isn't exciting for me. This is geometry doesn't do much, but you know what? You got to do it. And that is it. All right. So give me just a moment here, because it'll be right.
All right.
All right. So we got a proof here. Proofs are a big part of geometry, but they don't come up really in any other part of math. So the thing is that, like, when you had your algebra class, you just did this stuff on the left, but you didn't have to explain why. You just did it. Now you got to explain why. And that's kind of frustrating. So it's like you're trying to figure out, well, what did you do to go from the first step to the second step? And it kind of like we are talking about yesterday with the movie thing. It's like, well, like you're kind of right in the middle of the movie. So let me show you what they did to go from the first line to the second line. And I'll show you that here. What they did is they took this -2 and they distributed it to everything in here. So that becomes -4x cubed minus 8x squared plus 6.
Yeah, I remember a little bit of this.
So which two of these answers have the distributive property as the first thing?
The bottom two.
Bottom two. So using test taking strategy, you can get rid of some answers. So now, what is different between these after distributive property?
Combine like terms and commutative property of addition.
Right. So we have to decide to go from 2 to 3. Are you combining like terms, or are you using the commutative property of addition? And maybe you know the difference between them, maybe you don't. The commutative property of addition says that 8 plus 4 equals 4 plus 8. Combining like terms says that 2x plus 3x, you write it as 5x. So take a look from 2 to 3 and try to decide, are they just reordering it, or are they combining like terms?
I think they're combining like terms.
Okay, tell me which like terms they are combining then.
Uh oh wait, no. Are they just reordering it? Oh, they
Well, you got to
are.
decide. So sometimes you give me an answer, and I'm gonna ask you back. Well, then which one is it?
Yeah.
which, and it's okay to change your answer. I just want you to think through.
No,
Okay,
there's no like terms in there. I just
okay.
noticed that.
So then it must be the other one, but now you've got to tell me, well, what are they rearranging? What are they rearranging? So your eyes have to detect, what's the same, what's different? What's the same, what's different?
I think it's from biggest to smallest because like they have the power
So yeah, so
three.
yeah, what I was kind of hoping you would say is, okay, the 6 is there, and then I got moved over there. The 10 minus 10x got moved, the 5x squared got moved. You can see a couple of them got moved.
Yeah.
So, and that's what's meant by the commutative property of addition.
All
All right,
right.
so good timing here. We're basically halfway through the lesson. Why don't you submit this? If you got any wrong, let's go back and take a look at them, try to explain, but at least you'll have the right answers in your notes. If
All right. There was one wrong.
Okay, which one do we need to look at again?
Number 6. I just sent it to you.
Okay, let's take a look here. Number 6. Number 6. All right. Okay. I see. So yeah, I see. The angle is 30, but it was asking about the whole thing. FJH. So we know that each of them are 30. 30 plus 30 is
60.
60.
Yeah.
That's why that one is actually correct. Sorry about that. Sometimes I don't pay attention.
No, it's totally fine. We all make mistakes. Just whatever.
All right.
As
Well,
you
whenever
said,
you're
you
ready.
are an adult.
Yes, yes, adulting.
All right. This is a big one. So
You're going to start moving into proofs, and there's going to be a lot more to sort of do that. All right. So if it's at all possible for future questions, if you could narrow the screen to maybe a half here to sort of like get it so all this text on the right um, comes down to the next line. If you can squeeze your screen like that, maybe make it half screen. Is that at all possible?
uh oh yeah, okay. My bad. I didn't know I could do that. Want me to like resend it?
Yes, if you don't mind. It just when they go on and on like this, it's hard to read.
Yeah, no, I got it.
There it is. As you can see, the picture also gets a little bit larger, and you're welcome to start sending over a bunch more. Oh, that's number 2.
Yeah, there's only 5 of them this time, but they're just like big questions, you know?
Yeah. Great. Let's get rid of these out. All right, so here we go. We got Diane and Joby wrote the following proofs to prove that vertical angles are congruent. Who is correct? Basically, they're giving you 2 proofs, and you have to decide who is correct. Now, you've probably heard this in English class. You cannot use the word to define the word or something like that, where they say you can't use the word to explain what it means.
Yeah.
You heard that before?
Yeah.
It's the same thing in the proof. You can't prove vertical angles by using vertical angles. Okay. But the way the answers are written, all that means is that we know that for sure Joby is wrong. Okay. So it could be that they're both wrong, or that Diane is right and Joby is wrong. But just because Joby is wrong doesn't mean that Diane is right. Do you follow that sort of logic sequence?
Yeah, no, I get that.
Okay. So let's see if Diana is right. She's saying that angle 1 plus angle 2 is 180 degrees. That is true. Angle 1 plus angle 2 is 180 degrees. Here's how we know. They make up a linear pair. Linear pairs add up to 180. It falls in a straight line. That is true. Then they're saying Angle 1 plus angle 4, similarly, is also definition supplemental. So those angles there, angle 1, angle 4, they are also definition supplemental angles. That's great. All right. Now, is what they're doing in this next line here is they're saying that because angle 1 plus angle 2 adds up to 180, because angle 1 plus angle 4 adds up to 180, they must be equal to each other, which is true. Okay. Everything they've done here is true, but they have not finished the proof because they've not written a line that says angle 2 is congruent to angle 4. They're missing this.
Yeah.
It's missing. So neither are correct, unfortunately.
All right.
It's an odd way to look at life. I mean, we default to truth when we talk to people. You know, we really can't live in this world if we, think everyone's out to get us. But in these problem sets, you have to consider that, well, maybe they're both wrong. We don't know. All right. Let's grab the next question here. Looks like these are all 2-point questions now. All right, the following is an incomplete paragraph proof that angle WRS, so WRS, so that's this angle here, is congruent to angle BQT, so this angle here. All right, now there's like, boy. So like, it's hard for me just not to give you the answer because when you have two parallel lines cut with a transversal, these are all possible. Alternate interior corresponding, same side interior and vertical. Like they're all possible and it's all based on two lines cut by a transversal. Do you remember this at all from when you took the class?
I'm a little like shaky on my memory, so it's not.
Okay. Well, the short of it is that if there is that this is in the interior, this is in the exterior. There's side 1, which is like to the left, side 2, which is to the right.
Oh, okay.
All right. Now, I don't know if that's enough, but it's enough to tell you that they're not same side interior. Okay. Now, vertical angles are these, kind of where there's an X. You want to think of X angles? What do you think? Are these vertical angles or not?
No, doesn't look like it.
It is not. Okay. So that one's out as well. So now it comes down to, are they alternate interior or are they corresponding? So are they in the interior?
Yeah.
They are. So it's looking pretty good for that one. They are not corresponding. Here, let me show you what angles corresponding represents here. All right, so angle 1 and angle 5 are corresponding. Angle 1 and angle 5 are corresponding. They're in the same relative position. Like I mentioned that, like it's, you've ever been somewhere where like you go to like room to room or a hotel room, everything looks the same. Like the
Yeah.
bed's on one side, the dresser's on the other. That's kind of the idea here. It's like top right, top right. Angle 2 is
Oh,
congruent to angle 6. Top left, top left. They're corresponding.
yeah.
All right. Same thing with angle 3 congruent to angle 7. Bottom left, bottom left. Angle 4 is congruent to angle 8. Bottom right, bottom right. All right. So these angles are not corresponding that we're looking at here because they're not in the same position. One's bottom left, one's top right. And that's why that one is out, and that's why they're alternate interior.
Yeah. Okay.
Any questions on that?
No.
Huh. All right. All right. go to the next one here. More proofs, man. Pain and suffering. That's what they're doing here.
Oh wait, you're on number 5.
Okay, let me go back. I thought we did. All right. Looks like you might have sent another one here.
Number 3 should be the one we're
Yeah.
on.
All right. Yeah. So is this number 3?
Oh, that's number 4.
All right.
Did I send number 3?
I don't think you did.
Oh,
Why don't you just resend it? It'll just be easier than me trying to fumble around or here and figure it out.
yeah. All right. All right, there you go. I just sent it.
Okay.
And I don't think I did. My bad.
There we go. There's 3. This is yet another proof. Proofs are brutal. They're very difficult for most students. Unfortunately, they're part of this course. So we'll kind of go through it and explain what's going on here. So use the figure to answer the questions that follows. It says that I can't really read that. Easy. UV is parallel. So they're saying that these are parallel.
Yeah, UV and WV or
So
WZ.
yes. So what that means is all the stuff that we just talked about is true, but they're proving some of that. So the first thing they're saying is SQ, R, and T, SQ, R, and T, they all lie on the same line. I mean, it seems like a silly thing to say, but you have to say that. You say, okay, they're all on the same line. Now the measure of angle SQT, that straight line is 180 degrees. That's good. You're saying that like when you have a straight line, that measure is 180 degrees. Measure of angle SQV. So that's this one here, that's SQV. And measure of angle VQT, that's this one here. They're saying that equals the whole angle. They're saying that this angle plus this angle equals the whole angle. And that's reasonable. That's what this is here. Now, what do we know that this angle equals? What does it say in
180.
the previous 180? So the next line here is that these two angles add together to equal 180. So let's go see if we can find that in the proof. Do any of these say that these two angles add up to 180?
The second one
And the fourth one, which
and the
one is
fourth
it, or
one.
what's the difference between them, if any?
Oh, the second one is the same, and then the fourth one, it looks like they switched
Okay,
the.
so we obviously want to use the one that's the same. There's your final answer.
All right.
All right, let me see if I can actually get this. Number 4, I got 5. There's 4. All right. The 4 is this. There's 3 types of proofs that you'll see in this class. There are 2-column proofs, paragraph proofs, and then flowchart proofs. And this is a flowchart proof. It's a little hard to see, but they want to know about reason B. So they want to know how can you go from here to here, basically. And that's what we're going to try to figure out. So what I want you to look at, I know it's really hard to do, but maybe you could just focus in on these 2 steps. And I know there's a lot of letters and stuff, but maybe you can see like what is different about them or what is the same about them? Like, what do you notice in there?
Um, it has all the things from like the top from reason B, and then it kind of just adds like a little bit more to the bottom.
Okay, be more specific. Does it actually add something
Well,
else?
there's a subtraction now.
Okay, so we're looking for the one that has subtraction in it.
So the bottom one.
Yes. And truly, sometimes it's that simple. It's that simple. You don't have to overcomplicate things in this class. All right, so let's go to the last one here. Or it says, so given BC is parallel to ED. So these lines are parallel. That's what they're trying to show you here. They're parallel. And if they're parallel, like all this stuff that we've been talking about earlier with corresponding and alternate interior angles and vertical angles, all of that applies. Well, let's see what they're doing here. They're saying that ABC is 70, CED, so this angle right here is 30, okay? And we want to prove that BEC, so we're trying to prove that this other angle here is 40 degrees. We're trying to prove that. All right, so we actually know that it's true because when two parallel lines are cut by what's called a transversal, this angle up here equals this angle down here. Now it's the whole angle. The whole angle
Oh,
here.
so
Okay,
like
so
30 adds to
40 to get 70. Yeah.
yeah.
And what they did is they added in like, oh, we're going to break it apart so that this one's 30 and this one's 40, but it's still true. So let's take a look here and see what's going on here. So first thing is they say it's parallel. They say that this angle is 70. They say that this angle is 30, given, given, given. So you always start your proofs with given, given, whatever the givens are, you start with that. The next thing they say is that this angle up here at the top, ABC, measure of angle ABC, this 70, is the same as measure of angle BED. They're saying these angles are the same because they correspond. That's what we put over here on the right. Now, because they correspond, we know that, well, they must add up to each other. Like these two little angles here, the 40 and the 30 must add up to the 70. So that's what they're doing here. They're saying that BEC, okay, which is what we're trying to find, plus CED, which is 30, must equal to BED. So they're saying the measure of angle BEC plus 30 equals 70. Okay, so notice that all of these say that. Well, sorry, the last two do not. Sorry about that. So we can get it down to at least two answers. That's good. It's really good when you can do that because if it's better to guess with two than to guess with four. All right, now what allowed us to do that? What were we doing? We were taking the angle measure and replacing it with a number.
You were
Which
adding?
word? Well, we are adding now, but you have to think of it as like from this step to this step. And I can see why you would say adding. You're actually substituting. You're replacing.
Oh, I thought that said subtraction. My bad.
Okay. Okay. And now to be fair to you, like they are adding here, but that's not the reason.
And no, I
You
thought
also
that said
generally,
subtracting. It's my bad.
yeah, you also generally don't. Well, let's say that for a different time. Okay. So any questions on that?
No?
All right. Why don't you submit that and see if there's anything to correct there, and we'll talk about what we're going to do next.
All right. Got number 2. I just sent it to you. And then number 4.
This was not correct.
No.
WRS.
It says it would be corresponding.
VQT is near to WRS. All right, so I'm going to see what you sent in the chat because that doesn't really look right. Let me take a look at this here. All right. WRS is this angle right here, and VQT is this angle right here. There, because angles SQU. Okay, I'm sorry. So okay, guys, this is my fault. While these are alternate interior, the angles that they're looking at SQU. Let me do that different color here. SQU is this one, and WRS is this one, Those are corresponding.
Oh,
Okay,
yeah,
so the mistake is not, looking at these carefully, which is really on me. Now you said 4 is also a problem here. If you want to send that over, we can take a look at that.
yeah, I sent it. Or oh wait, no, I didn't.
I believe you can do a retake on these, but they give you new questions.
Um, they
You may
might.
you may want to check on that. So we said reason B,
Yeah, we picked subtraction. Or yeah.
isn't it subtracting both sides? Huh. Well, okay, let me take a look here. You're subtracting from both sides. Hmm. I don't really follow this because you are subtracting. Um, the reason, unless the reason, so maybe the reason is meant to be associated with this line, like how you went from this line to these lines together. I'll know that I follow that, but let me take a look here on the left. So the given is the reason. So the thing underneath is the reason. Okay. Um, yeah, it is what I've just said here. Okay. So it's saying that VQT plus measure of angle ZRS equals 180. You're substituting in for VQ for 180. You're substituting in for that. Yeah. Okay. So what you're doing is you're taking, let's see if I can show you here. This right here, which equals 180, is getting substituted in for 180. That's where the substitution comes from. Right. So I think you get a retake on this. Correct me if I'm wrong.
Um, doesn't say. Wait, which
Well, I mean, you may want to look into that because they may be the same. They may be really, really similar. They may only count the highest score, so you don't have to worry about if you bomb it or have an issue.
yeah, no, it's only there's only one attempt for each one.
Okay, so one of the things you could do here, I know this probably isn't super comfortable, but you could always email your instructor and just say, hey, I didn't really follow these, and I'm not sure, and see if they'll give you another attempt. Sometimes they will. Um, but what I think and I'll just reiterate that you probably want to get down. Like, I don't know if you can print your quizzes each time. You really want to be able to go back and take a look at them for your tests, have them out so you can find them because all the questions are going to come from your homeworks.
Yeah. Oh yeah, I saw your YouTube video yesterday. I thought it was pretty cool. I
Yeah.
rewatched it.
Thanks for liking it. I do appreciate that.
Also
You're welcome.
subscribed.
Cool. So there's actually another student who's taking a really similar course. His name is Karthik. I believe he's in the honors, but questions are really similar to what you're doing. So you might consider looking at his, but he kind of stopped doing the multiple choice. We've been mostly doing proofs and the free response stuff. So you're welcome to check out, other people's student lessons. But
Yeah, I was looking at that. I thought it was pretty cool. You have
great.
like 2,000 videos. I'm like, holy crap.
Most of them are student lessons. I mean, they started doing a bunch of other stuff, but if you want to get views on socials, you don't do math. You do comedy, crazy. You do something else. So,
Yeah.
the reality. That's